And then you just give them different colors. So the bar color of one is gray, the bar color of the other is maroon. And that's it.
I have a question.
Yeah.
I was just wondering, what is the note, parentheses, two quote, is it two quotes? What does that mean?
It
Like, what does it
turns off, there's a note that goes on. Whenever you do a bar graph, it tells you graph by that variable. And it's just a personal preference. I don't like it. So, yeah, it's in the bottom left-hand corner. So let's go back to that first one. And because usually you have the labels anyways. Right? I got a big giant label that says Sonoma, a big giant label named Napa. I don't have to tell you that those are graphs by region.
Okay.
So it just seems to me redundant. And it just draws the eye, really, more than anything else. So I usually turn it off. All right. And you can do some box plots and all those kinds of things. So let's do a quick box plot. And then we'll move on to a regression. These are prices. Again, a lot of outlying prices, a lot of high prices for those Napa wines. Remember, we can get rid of these outliers. If we get rid of these outliers, we can see these, what are called interquartile ranges. The squares, the middle 50% of the data, a lot more, it blows up that area, so you just use the no outlier or no out option. And that gives you a different view. So you can see no out at the end. That just means no outlier. We use that, I think, already. But essentially what that allows us to do is kind of see these boxes a little bit more clearly. So we can see, for example, the Napa one almost is perfectly on these two y-axes. The middle 50% of those Napa wines are between 20 and 40 bucks. The middle 50% of the Sonoma wines, I don't have enough, this is probably 20 and 15 maybe. So if you go 15, 10, yeah, it's about 15 bucks. Or the middle 50% of the Sonoma wines are between 15 and 10 bucks. And you can see that a little bit more clearly with these box plots. So one of the reasons I like it. And as you know, we can do graphs all night long. So if you want to order some pizza. All right. This is that simple regression that we did. Just regressing log price on score. And that gives us the ratings function. Essentially what we're doing is taking this and saying, okay, ratings does seem to be, people do view ratings as a measure of quality. They're willing to pay more for wines that are rated higher. But essentially what we do is we take this and we break down the data, because this is all the data. So we break down the data into 4 parts. Napa Zin, Sonoma Zin, and Napa Cab, Sonoma Cab. And that's what the regression does. It breaks it down into those 4 component parts so that we can then calculate those ratings premiums and then the Napa premium, as well as the brand premium. We already did that. We did that. All right. So what do we do now? We go back to the model, and we're going to generate the interactions. So everything now is an interaction with stuff we already got. We already got Napa, we already got Cab. Now we're just multiplying everything by each other. So Napa Cab equals Napa times Cab, Napa score times score cab score, cab times score. The triple interaction Napa cab score is going to be Napa times cab times score. And this is model 1. And I think these results are going to be different than the ones in the paper, because the model's a little bit different. I don't remember, to be honest. But essentially, here are our coefficients. So remember, if it's a Sonoma Zinn, everything is zeroed out. It's not from Napa because it's from Sonoma, so anything with Napa is going to be 0. It's a Zinn, so anything with cab is going to be 0. So in essence, Sonoma Zinn is simply that coefficient of 3.5. So for Sonoma Zinn, every 1 point increase in a wine spectator ranking results in a 3.5% increase in the price people are willing to pay for that wine. And that effect is statistically significant. Nice big t-stat of 34. And then for a Sonoma Zinn, for a Napa Zinn, you would throw in Napa score. And you can see the difference is going to be relatively small, about 1%, although it's still statistically significant. But the difference between Napa and Sonoma, difference between the ratings effect of Napa and Sonoma Zinns is going to be relatively small. It's going to be 1%. And we can kind of plug in all the numbers we need. Again, what you should be doing anyways, what you have to be doing anyways, is outregging this stuff. And once you outreg it, right? Once you outreg it, you can pretty much, this equation, for example, Sonoma Zinn, you can just put beta 0, refer to that cell, plus beta 1, and you can have a score in there of 0.85 or something. This is the simple model without score squared. But once you outreg it, you can access those coefficients and calculate those, for example, Napa premiums between Napa and Sonoma Zinns and cabs pretty easily. I think I mentioned this, but if you're using outreg, it's not a problem. If you're using outreg, is anyone using outreg? Because there's outreg 2. Okay, so you're all using outreg 2. So if you're using outreg 2, there is one problem, and there's a reason why there's 2 outregs. But if you notice in outreg 2 that it'll give you the, so let's say this is score, and then it'll give you the t-stat underneath. We use the brackets because we don't want to do that. And if it's statistically significant, it'll put the asterisk here. If the asterisk is there, you can't access that cell.
Yeah.
Because it treats it as a word. So you need to add one more option to your outreg. And it's pretty simple. No asterisk.
Is that one word in caps?
Yeah, one word, no, just one word in lowercase.
Does it matter where it goes?
It's
After bracket?
after the bracket, or there's a comma in there somewhere, it just gotta be after the comma. So just put it at the end, no asterisk. I like the asterisks because you can see which ones are significant, which ones aren't. But if you're gonna want to be able to make these calculations, the asterisks get in the way. The nice thing about outreg is that outreg puts the asterisk on the t-stat instead of on the coefficient. So we don't normally access the t-stats. So outreg is nicer in that context, but outreg 2 has a ton more functionality. We can use IDOT because outreg won't recognize IDOT, but outreg 2 does. So that's a nice, it's a nice thing to know. Otherwise, you have to go in there and delete the asterisks, and that's time spent doing something you'd rather not be doing. Okay, so let's let's move to model 2. Oh, this is factor variables, but we'll skip that. So there's two ways to include the brands. We can encode the brands. Remember encode? Did we do that?
Yep.
Yeah. So we can encode the brands, which converts them into a number, and then we can use IDOT. So in this case, our variable for brands is, so there's two ways to do this. Our variable for brands is it brand? Yeah, it's brand. So if you tab brand, these are the actual brands in their words. So you can't IDOT words. You got to convert these to numbers through encode, and that's pretty easy. So if you want to use IDOT, encode brand, comma, gen. You got to give brand a new name. How about? We can't give it the same name. Brand 2. It's not brand square, brand 2. So now if I tab brand 2, it'll look exactly like that. But if you add the option no label or no lab, you'll see that they're actually numbers. And number 1 is, and it goes alphabetical, so number 1 is probably going to be Andretti again. Yep. So we can use IDOT if we wanted to. The other thing you can do is use the tab gen. So if you tab, have we done that? This is an alternative to encoding if you don't like encoding. But what this does, so tab just lists all the dummies, right? But if you add in that comma gen brand, and notice I had to call it something else, so I called this one capital brand with a capital B. And Stata is case sensitive, so it matters. Adding that gen brand is going to generate a dummy for every one of these brands. So if we go to the data, so scroll down over here. There's brand 1 through, that's a dummy for Andretti, so 1 if you're Andretti, 0 if you're not. There's going to be a dummy for all 107 brands. You got to leave one out. It doesn't matter which one, but I usually leave out the first one just so I remember which is which. So again, you can run this regression one of two ways, using IDOT or the tab gen. They're going to give you the exact same results.
So if we were going to do the IDOT, like after we encode it,
Yep.
literally all we have to do is add IDOT brand once we do the encode, whatever.
Let me do it. Yeah, let me do it. So I did it the other way, which means I got to delete. I got to delete those. So now I'm going to just do IDOT. I call it brand 2, right? IDOT brand 2. And this is why you don't want to show the. So it's going to outreg this. You just don't have to include the brand coefficients in your. So just drop it or delete them all in your Excel file. So here you go. And I used IDOT brand, which is the way I would prefer actually. But the results are going to be the same, exactly the same. Here's all the IDOTs, and these are the coefficients we're going to use in your outreg. So you want to include the coefficients, your R squared and all that stuff. You don't need the 107 brands, so 106 dummies. So we got a big ass cab and and that is model 2. For model 3, what time do we got? Okay, so remember what we're gonna do, we're gonna add basically score squared. And the notation for that is I'm gonna generate score 2 equals score, and that's the caret squared. And then anything with score in it, in our regression, anything with score in it, we need to add a score squared. So we have score, we added score squared. We had Napa score, we added Napa score squared. We had cab score, we added cab score squared. We had Napa cab score, we add Napa cab score squared. So we're going to add those 4 more, and those give us the nonlinearities and the regressions. And did I run this yet? No, I haven't run the regression yet. Let's see. And again, in your Excel outreg, get rid of the brand effects. And we are, right, this is the stuff we want. Again, these are a little bit different. By the way, I didn't mention it, and I don't know if you noticed it or not, but the first R squared we had, which is our measure of how well the model fits the data, was in the 40-ish range. The model now, with our square terms, is in the 86 range, which is pretty good. Now these results are a little bit different than the results that I showed you from the paper, because we left out some things that I did in the paper that we don't need to cover in this class. But this is what the model you guys are going to do. The hard part, I think, is, like I said, it's the housekeeping. Getting those 4 equations, making sure you put things in the right spot. You don't have to worry about the brand effects, because those are all shifters anyways, so they're going to all zero out. And just worry about the ratings effects and the Napa premium. You're not going to be able to graph these, so don't even try. Because it's you're not going to get a smooth regression like the ones I did. You're going to get really jaggedy lines. So the only one, I think the only ones you can, once you add the brands, you can't graph this stuff. And then of course the squared stuff. So everything's going to go by your interpretation of the regressions. Now the way I was able to graph them is I kind of cheated, is because you get a graph, but it ends up looking like that. So for the paper, what I did was I ran a graph through, I ran a regression of my regression output, and I got something like that. So I'm not asking you to do that. That was purely for aesthetic purposes. Because essentially, remember, the brand dummies are shifters, so each brand is going to shift that line up and down like that.
Is that similar to just taking the derivative like you would in calculus, or it must be a straight line?
No, that's actually, taking a derivative is what we're doing for the brand effects for the nonlinear model. That is running a regression on the regression, so it's a double regression.
Have you seen Inception?
Yeah. You gotta drop some acid to understand it. Or have a glass of zin, or both. All right. Any questions? Seem doable?
We'll see.
We'll see. Again, don't, as nasty as this looks, and it is pretty nasty, I mean, this was a well-received paper, the methodology was unique. Just kind of remember what we're doing. we're quantifying ratings effects, brand effects, and the regional brand of Napa and Sonoma. So we're doing something that's pretty awesome.
So when talking about brand loyalty then, how are we looking at, like, are we like gonna, I don't know, but
So we're putting a dollar figure, kind of a dollar figure on brand loyalty in terms of regional brand. So how much are you willing to pay for the Napa
and
brand?
Sonoma, not individual.
Yeah, we're not gonna analyze the individual brands. But we know
Okay.
that once we included those individual brands, the regressions changed drastically. So we know they had an effect. So keep your eye on the big picture and
So I
I think it'll help.
Napa has a high.
Yeah.
Do we look at the Napa variable?
Oh yeah, so that Napa is a shifter, so it's gonna be that distance. But remember, there's also the difference between Napa and Sonoma ratings effects. So depends on which interactions you're looking at.